with the architecture. So as we have seen in the videos, we are basically having a fairly simple set of functionalities. The program can draw polygons, lines, draw labels, and so on. And you can save the drawing. You can also undo and redo the operations. So let's see where, let me see why I'm not able to. Okay, yeah, all right. We have three subsystems. So we are actually designing this using what is called the MVC pattern. So there is a model, there is a view, and a controller. Oops. So there are three uh, sets of classes. So model is not just one class. I mean, technically, it is just a group of classes. View also would be a group of classes. Controller would also be a group of classes. The idea is that the model will store all the data. So in this case, the data is essentially the shapes that you draw in the drawing program. And the view would be the set of classes that show you what the model contains. The view decides what to show. Of course, it is dependent on what is in the model, but then it can select what it wants to show, and it can select, it can also decide how to represent that. For example, it could show all the shapes, or it could say, I am only showing rectangles, or I am only showing things that were drawn in the last 2 hours, or it could simply summarize the information in a textual format, but that may not be very useful, but it could be done that way. The controller receives all the input. And as you have seen in the videos and readings, the controller gets data from the user. So the user is sitting here. All the data, all the commands, everything comes to the controller, and then the controller might create shapes and put them into the model, or it might suddenly tell the view to do something. So all the inputs go through the controller, and the view displays all the information. Now, if you read the book, chapter 11, that is the old version of the drawing program. You can, much of it is valid, or a good part of it is valid, but not all of it in the version, in the program that I have uploaded. The difficulty with that design is that there is a fourth component that is present in the system, that is the actual devices that you are using. You are using the keyboard, you are using the mouse, you are seeing things on your computer display, and that is dependent on the technology that you are using. For example, you might use JavaFX. So I wanted to separate JavaFX from the rest of this, so that even if you wanted to change the technology here, you can easily do so without having to worry about what is going on inside these. So these three modules these three subsystems are pretty much independent of the actual technology used, so that you can take this stuff and move it to some other system. Maybe you can put it on Android and have a little drawing program there. Instead of using JavaFX, you will use Android's UI technology. Okay. So all you have to do is replace this part. The rest of the stuff is independent of the actual technology you are employing. The model view controller is what is called an architectural pattern, because you are having three subsystems instead of small number of classes. Of course, relatively speaking, we have a small number of classes compared to commercial software. Of course, we can't have such huge systems studied in class. We have to have fairly small systems. This is unlike design patterns where you may have a couple of classes, a couple of interfaces, and that's it. So that is the first part. Let us now take a look at the code a little bit. And before we do that, I want you to read the document called Drawing Program Description under Content rather than the book. You can go to the book too, but focus more on the drawing program description, because that is what we have implemented in this software. And you should download and look at the code. So let's look at the code here. So I'm going to share the Eclipse program with you now. Okay. So if you look at this code, this is the code that I have uploaded, class project 3 version 1. There are basically 4 packages here. One is model, another one is view, the third one is controller. So the model contains essentially the model subsystem, this contains the view subsystem, and controller contains the controller subsystem. And all the JavaFX code is here. And it is not just JavaFX code, there is also Swing, because I wanted to mix the two and show you certain possibilities. Right? If you expand these, you will see a large number of classes, but most of that stuff is fairly simple in nature. So you have to understand the wiring among the various components. So the controller class, controller subsystem, I should say, has these packages, commands, events, and states. Events are things like you're clicking using the mouse or pressing a button. So things that you request. And instead of calling them by their Java names, I'm saying things like abandon event, character event, confirm event. Abandon event means you want to abandon the current operation, or confirm event means you are ending, you're confirming something. It's basically the escape key that is viewed as a confirm event. I couldn't think of anything suitable for mouse enter event and mouse exit event. They are pretty much the Java event names. Then to create shapes, I have create line event, create label event, etc. So let's look at one of them here, create label event. It is a singleton. So whenever you press the button to create a line, this event occurs. There are similar things here. Point input event is basically mouse click. So when the mouse is clicked, you can get the X and Y coordinates. So this event captures that information. So whenever you click the mouse, an instance of point input event is generated and sent to the controller. So the controller gets these events. So the controller is an interface.
One question about this, is this
Yeah.
with the bridge pattern? Because I see the swing view event and the FX view event.
Yeah, we have this. I will get to that.
Okay.
Yeah. It has the swing pattern, sorry, bridge pattern, yes. Controller is an interface. So there is a method for everything that can happen. So this is like the microwave, you know, I mean, there are so many events that can happen and you have to handle all of them. Some of them are applicable in some states, some are not. So handle event, handle event, handle event. It's the same method name, but this is the parameters are obviously of different types. So for every event here, I have a method here, more or less. A couple of them, like FX view event and swing view event, are directly handled. I may still have the methods here, but they are not used if they are still here. Then I have several states here. When you are drawing a line, you go into this state, line drawing state. So let's take a look at this. So if you are drawing the line, this is the state that is active, and it handles certain types of events. When you click on the screen, this event is called. In fact, that is the only thing that you can see here, right? So if it is the first one, first point, first endpoint of the line, then it stores that information. Otherwise, it stores it as the second one. So the controller is actually implemented by the context. We have a microwave, we had a microwave context in the for microwaves, right? So we have a similar thing here, the drawing context. And the drawing context handles all the events. So there is one method for every event. And all it does is it tells the current state to handle it. That's it. It is just a router. When it gets an event, it tells the current state to handle it. So there is nothing difficult about it. You see, everything is one line here. So all these events know about the drawing context. They don't know what is going on inside the drawing program. So whenever an event is generated, whenever an event occurs, that event simply tells the drawing context, look, this event has occurred. You do what you want with it. And this tells the current state. It knows what the current state is, right? So there is a field here that says what the current state is. It tells the current state, you handle it. And the current state would do it differently for the different shapes. For example, the polygon drawing state would be a little more complicated than the line drawing state because it has to worry about more than 2 points. So it has to make sure that there is a shape that is closed. It has to know that something is the last point, etc. So there is a little more complication here. But again, you can see that it's not a substantially large state. As I'm repeating here, it is the wiring among these that you should really be focused on at this point, not the intricate details. Now, the model has two parts. One is a collection of shapes. So if you want to add a new shape, you will put that shape here. So there is a superclass called shape, and there are subclasses like line, polygon, circle. You can have, I mean, I haven't implemented circle, but you can implement it by adding a class here. So what does a shape do? You can render it on the screen, and you can do certain things on it. Like if you have a line, you can get the first endpoint, second endpoint. And all of these shapes can be serialized so that you can save the drawing. Then the model class is just a collection, like member list or catalog in the case of the library. Um, so you have actually a list of shapes. It is a singleton. Okay. And the most complicated part of it, in my opinion, is this part, the view. This view here is basically a couple of interfaces and a class. This class is going to render the stuff, is going to render all the shapes. So let's go back to the whiteboard and talk about that for some time. All right, so what the view does is it looks at what is in the model and renders those shapes. So the view is essentially an observer. And the model is the observable. So whenever you add a shape to the model, it tells the view. Whenever something happens within the model, it tells the view. So the view is actually observing the model. So, and it looks at the model and then pulls all the data and then displays that on the screen through JavaFX. Okay, so that is the most difficult part of this whole business. So let's look at that a little bit in detail. So so when the view decides that it has to show stuff, what it does is it goes through all the shapes. It calls this method model.instance.getShapes. Give me all the shapes. And it goes through the shapes, each one, and tells each state to draw itself. So there is a render method that we had a brief look at. And what the view does is it tells each shape called item to render itself using this renderer. What is this renderer? This renderer is the actual technology dependent stuff. Renderer, this renderer with a capital R is an interface. So let's look at that. There are many implementations of it. I mean, potentially there are many implementations of it. You could have a swing renderer, you could have JavaFX renderer. If you had a third technology, you could have a third type of renderer and so on. So if you look at the renderer interface, what can it do? It can draw a line from the first point to the second point. It can kind of draw a piece of text. I mean, that is the technology, that is a terminology used in Java, so we use the same name. Draw this piece of text at this coordinate. We can draw an arc, and this catches all the other ones. You can also set the color of the drawing, and you can also draw one single pixel. So there are several things that a single renderer can do. But if you look at the code here in Vue, it simply uses this renderer interface. It's not saying whether it is JavaFX or Swing or some other technology. The actual implementation of it is in here. If you go to Vue, and there is a package called renderers. There are two renderers here. One is FX renderer. It uses all FX technology. So if you expand the imports here, you see Java FX stuff. So it uses the Java FX API to draw arcs and lines and so on. Whereas the Swing renderer uses the Swing technology, obviously. So you see things like okay. So it uses, these are basically things in Java Swing. So what the Vue does, the Vue class, what it does is it tells the shape to draw itself using the renderer it chooses. Who chooses, how does it choose it? It depends on the actual type of technology being used. So that is where the bridge pattern comes in. So let's talk about the bridge pattern. That is an important pattern, very useful one. So let's talk about that. This is crucial to understanding the way things are drawn. Let me clear all this. We have many types of technologies, let's assume. So we want to use Swing, we might want to use FX, we might want to use the abstract windowing toolkit, etc., etc. Maybe 5 years from now, they might replace FX with something they think is better, all right? So if you want to cater to all these technologies, what is your choice? If you're drawing a line, think about a line. It has two endpoints. So the line class knows where the first point is, it knows where the second point is. But if you're drawing using Swing, the API for Swing is all going to be in some class where you are rendering a line. So there is a conflict. This is technology dependent. Tech dependent. This line class knows about a line. So there is a conflict. If you want to know, if you want to have the line class render everything, because the line class knows where the two endpoints are, without knowing that you cannot draw, then you have to put all the Swing technology in here. But then it cannot draw FX. Whereas if you go to any piece of code that uses Swing, how do you know where to draw a line? That has to come from the line class. So there is going to be a problem, right? So to handle this, we are using the bridge pattern. So what we are having is essentially the shape class. Whenever you add a new shape, you add a new subclass. So we can have line, rectangle, polygon, and so on. And the line knows where its endpoints are, the rectangle knows where its vertices are, and so does a polygon. But then how do you get this polygon or line to be drawn in various technologies? So for that, we have this renderer interface, as we just saw. And we create, and as you saw, it has methods for drawing lines, drawing a piece of text, drawing an arc. So we can have different implementations of it for FX, swing, and so on. So what is happening is the shape remembers the renderer. The shape knows which renderer to use. This is abstract. This is also abstract, but every shape knows has the reference to a renderer. So it would be a concrete class, obviously. So the line might be given a renderer for FX. Then it will use the methods of the renderer class without exactly knowing which renderer it is. It knows that every renderer is capable of drawing a line. So it will tell the renderer to draw a line. If it is the FX renderer, it will draw using the FX technology. If it is a swing renderer, it will use the swing technology. So this is called the bridge. We have two hierarchies, basically. In this case, we have shape hierarchy and renderer hierarchy. So in a bridge, we have two hierarchies, different types of classes here, and they use methods of the renderer interface. So if you have methods M1 and M2 here, line might use M1, rectangle might use M2, polygon might use M1 and M2. So the goal here is to render stuff, and some may have fewer requirements, others may have more requirements, but we design the renderer interface that would hopefully capture the needs of every shape that you might add even in the future, right? Not things that you want to add right now, but you are trying to be clever and saying, okay, what all things would I need in the future? And you're betting on your ability to foresee those needs. So this is an important design pattern called bridge. So it is good to have two hierarchies, one hierarchy using this second hierarchy's methods. If you don't use the bridge pattern, then you will have to create a line class that draws for FX, a second line class to draw swing, a third line class to draw whatever this is, maybe aught, then a rectangle class for FX, a rectangle class for swing, a rectangle class for aught, then a polygon class for FX, a polygon class for swing, polygon class for aught. That would be too many classes. That would be a class explosion, which we can avoid using the bridge pattern. So that is the most intricate part of this program. The other part, which we discuss now, is very useful but not all that hard, and that is called undo redo. You know
Professor, can
what
I ask
undo
one
and
quick
redo.
question about bridge
Yeah,
before we move on, please?
sure.
So most of us as computer science students have like taken geometry, right? So we're reasonably familiar with the domain of rendering shapes. If you need to do a bridge for a domain that you're not super familiar with, is the is
I
the
missed that last word. I mean, if you are interested in what
so
doing.
if you need to create a use the bridge pattern around a domain that you're not particularly familiar with, is there any advice rather other than maybe talking to a domain expert about what that might be?
Yeah,
Or is there
that's an excellent question. I don't know if, I mean, you are wondering whether um, whether the other end is capable of capturing everything that you might need in the future, right? Is that what
yes,
you
exactly right. How to plan ahead in that way.
I don't know. I think you'll have to talk to a domain expert. Yeah. And in fact, yeah, that reminds me, when your question reminds me of something else. I honestly don't know much about this, but I have used things like bridges when I write database programs. For example, there is a SQLite, JDBC SQLite bridge. SQLite is a type of database system, okay? Relational database system, but it's one of those products. And I'm writing a program right now that uses JDBC, which is basically Java's SQL. But Java's SQL, how do you connect that to SQLite? Then there is a piece of software for that. So all the SQL statements that you issue through Java would be converted to SQLite operations through that bridge. But then there is something called the JDBC ODBC bridge. So that would do a different type of translation. So for the same set of database commands, I can use different databases using different bridges. So I think it follows the same pattern, but I don't have the I don't have enough information to be sure that it is using exactly this kind of an approach, but I suspect they do. So I thought I will just mention it when I heard this question.
Thank you, Professor.
Okay. Yeah. Yeah. The other thing is undo redo. This is very simple, but very, very useful. As you know, we all do this all the time when we create documents. How do you undo and redo operations? I don't need to explain what undo and redo mean. So what we do is very simple. As you do things like drawing lines or rectangles or circles or writing text like this, what you want to do is you want to capture all these operations in units of commands. So everything that the user does, or just about everything that the user does, is uh, going to be modeled as a series of commands. So maybe you can say a command is to draw a rectangle. Maybe you can even go in finer detail and say rectangle means drawing 4 lines, right? So you're going, that is entirely up to you, how you want to do undo and redo. Or drawing a circle, I suppose you would consider this whole thing to be just one command. When you look at a piece of text, do you want to consider this to be the whole command, or do you want individual characters to be a command, or do you want words to be a command? Or you could say maybe every 3 characters. I don't know if it makes sense, but you could, right? So what is a command is up to you, the designer. But anyway, let's say this is one command, this whole drawing a whole label, drawing a circle is a command, drawing a rectangle is a command. We use a very simple approach in our drawing program. If you have, say, 3 commands issued so far, we put them on a stack. C1, C2, C3. So let's assume that we first drew a rectangle. We represent the whole information in a command object. We will see what that command object contains in a minute. Then we have a circle drawn. We put a command object for drawing the circle. Then we put a command object for the label. And this is the last thing that last thing the user did. At this time, the user says, oh no, maybe this label shouldn't have been there. So if the user presses the undo button. So what you do is you pop the stack and put that into here. So this C3 goes from here and it goes and sits here. And you do something with the model. The model contains essentially these 3 shapes, and we delete the command related to the label. So the model doesn't store shapes anymore, it stores commands. And each command stores the shape. So the model would say, I have C1 and C2 with me, and C1 will contain a reference to this rectangle shape. C2 will contain a reference to the circle shape, and C3 will contain a reference to the label shape. So these commands are all now going to be stored. And when you delete, when you undo a command, that corresponding stuff is deleted from the model. In fact, it could even be the shape that you store in the model. It doesn't really matter much. It doesn't have to be the command. You can, yeah, you don't have to really change that. There is no need to store the command. You can just store the shape. So the model doesn't really need any change. That may be how I implemented it. You can, because the idea is, it is better to actually implement undo redo on top of the existing system rather than modify the existing system. So there is really no need, I'm sorry, to store the commands in the model. Sorry, something funny is going on with my pen. Oops. Okay, a lot of mess here. Okay, now back to this.
It heard you talking about undo and redo and wanted to see how good a job it could do, Professor.
How good a job?
I was trying to be funny. It heard you discussing undo and redo
Yeah,
and wanted
right.
to test itself.
Yeah. Yeah, but actually I wasn't doing undo. I was using the eraser here. Yeah, there is actually undo and redo here. Yeah, I can see that. I didn't, yeah, let me do redo here. Let me see whether it works.
Hello, Professor. I have a question over there. I mean, like,
yeah,
there's a lot of classes here, and I was trying to figure out their relationships, how they communicate. And would you mind to give us, like, for example,
let's see.
Let's say, like, you add one more shape there, for example, triangle, for example.
Very good, very good. Let's go
And how we are going to do that, because there is a lot of classes where and
Okay, let's
how we
trace
are going to modify. Okay.
Let's trace one shape. That's an excellent point. Let's trace exactly one shape. Okay. Yeah. Then you will also see undo and redo in the. So let me go to one shape. All right. Let me do one thing here. Let me maybe execute something for us for 15 seconds or so, and then we will see. So to run this, you need to execute the drawing program. Oh, you may not be able to see the. Oh, I hope I have executed the right version. Are you able to see the drawing program at all?
No.
No, okay. I will then change my share. It's not right. Maybe I'll have to share the desktop. That is. That's not quite what I want to do. I think I will have to share the desktop. I can't find, over here, there it is, okay. All right, here is the drawing program. I click on the line button, I click 2 points here and I got the line. I can undo it and I can redo it. I can save it, I can open that. I'm not going to go through that. So let's see how, by the way, if you want to draw a polygon, you will draw like this. And at some point, I will hit the enter key and then it completes the polygon, okay? So let's see what the sequence of actions are. I won't be able to go through nitty-gritty details of every line of code, but I will show you the flow. And you can ask questions as we go through that. So let me share the Eclipse code again. Share screen. Actually, this is my most favorite program, but I get very little time to go through this. Okay. The drawing program has basically 2 panels. As you saw, there is a strip of buttons, and that is the button panel. And there is a place where the drawing appears, and that is called the drawing panel. And the drawing panel class is here. And it extends what is called the FX panel. The purpose of this is to actually, purpose of drawing panel, the purpose of the extension is to show the different shapes of the mouse as it enters and leaves that area. FX panel is going to contain the canvas where the drawing is going to be done. So it, I mean, it tries to present a nice window and all that. There is very little code here, as you can see, because most of the work is done through the renderers and behind the scenes. These things are all very small. So what happens when you issue the line drawing command? So initially, when you run the drawing program, here, when you run this program, it starts up the stage, it shows all the menus and everything, and the drawing context comes into picture, it gets initiated, and it sets the current state to quiescent state, meaning nothing is going on, right? So that is the first state. Quiescent state is one of the several possible states. So there is a super class called drawing state. It handles almost all of the events except a couple, which are to draw the effects and swing views. So the quiescent state, I mean, it does some work for some states, but as you can see, it is also empty for certain things. When you click on the mouse, on the button, where is that button? Let's look at the okay, actually I have to go to the GUI package. Here I have all the buttons and menu items and all that. So this is the button that we need to focus on. When you click, when you push the line button, what the line button does is it calls the handle event method on handle event method of drawing context with this event, create line event. As we saw, create line event is nothing but a singleton. It is just there to distinguish between various handle events, nothing else. So we go to the drawing context. Do I have it here? Yes. And again, the drawing context does something very simple. Handle event, create line event here. It tells the current state to handle it. It just dispatches that, nothing else. And the current state, as you know, is the quiescent state. Nothing is happening. So let's go to the quiescent state here. Here. And let's see what it does for create line. When it gets create line, that event, it tells the drawing context, change the current state to the line drawing state. So the line drawing state becomes the current state. This is very much like what you have in the microwave, changing the current state. So it goes to the line drawing state. Anybody having questions on this so far? Okay. Ideally, I would have liked to have every one of these drawing states divided into multiple states, but that is going to be also a little more difficult to understand. So let's see. We are going to the line drawing state, but we have, it is just there. That becomes the current state. It is doing nothing at this point. Then what happens? I click on the mouse. I click the mouse on the on that panel. So where does that take us? Okay. So we need to look at this. There is a set of handlers. This, I put all of them under the controller part of GUI because they receive input, right? So I call them controller, but I grouped the menu items and buttons into one package and key pressings and mouse clicks into a second package. One could have done this differently, but I thought this was reasonably logical. And when you click on the mouse, things happen here. So this class mouse click handler, which is very short, like many other classes or most other classes. It handles mouse events. So when the mouse is clicked, it simply checks whether the control is down or not. I don't quite know what I'm going to use this for control, but it is there, that's all. Maybe you can use it later, all right? So I'm not entirely sure there is any need for this, but I just put that in. But this is where you come most of the time. You don't press the control key, you just click the mouse, right? So every mouse click is thought of as inputting a point. That is the purpose. So what does it do? It tells the drawing context. So this object tells the drawing context. I have an event. What kind of event is this? I said a minute ago, all mouse clicks are inputting points. So it creates what is called a point input event. It asks the mouse, the event, what is the X coordinate and Y coordinate of where you clicked. So it captures those, creates a point input event with these X and Y coordinates. And the drawing context gets that information. And as usual, the drawing context is simply going to give it to the current state. See the division of responsibility here? The mouse click handler or the buttons, none of them know what the current state is. All they know is that there is this drawing context, which is the logical controller. So everything goes to that logical controller. And the point input event also goes there. And it tells the current state, and we know the line drawing state is the current state. So it responds to point input events. What it does is it creates a, for every shape, for every shape, as we saw, we are creating a command. So when you get this event, it could be that this is the first click on the line, or it could be the second click. We don't know. This may be the first point or the second point. If it is the first point, command would be null. Okay, I'll come back to that in a second. So command would be null if it is the first point. So what I do is I create a line command, and in that I store the point. This is something I need to change. I have things like point 2D, which is actually, I believe, JavaFX. So I'm going to change this at some point, maybe during the summer break, to my own custom points so that I don't have any JavaFX code here, right? So I will have something like drawing program point or some such thing, okay? Otherwise, there is little bit of JavaFX here. I don't want that. So anyway, I create a point that is having the X and Y coordinates. This is what is called a command object. The command object, let's take a look. Command class is under controller. Where is controller is at the top, right? There is a command class here. A command can do essentially three things. You can undo a command, you can redo a command, and you can execute a command. There is one more command that I added to signify that a command is over, so that you can do some wrapping up if you want it. So line command is one of the three commands, subclasses, because line is one of the shapes. So every shape has a command class. So you can identify it with this word command. And it stores the line object. And when it gets the first point, it creates a line object and calls the execute method. What it does is simply adds that line object to the model. As I said, I'm not storing the, I corrected myself before. I'm not storing the commands, I'm storing the shapes. Okay, let's just, so what happened? The model has the shape now. That line shape is stored in the model. But of course, it only has the first endpoint. It doesn't have the second endpoint. Okay, now line drawing state. Let's go back. So we created a line command. This, when we went into the line commands constructor, it created the line object, stored it in the model, and we also do one thing here. We remember that command in the context. If you recall from the microwave, the context is there to store global information across the states. So it can store, it can remember what the last command is. It is very useful, or what the current command is. That is probably more important. And so we remember the command so that when the second endpoint is clicked, we get that command, and that will not be null, and we will be going to this side where we will be telling the command to set the second endpoint. So this is the line command. It has a method to set the second endpoint. I'm not really using the index. At one point, I had an array here for lines and all that. So anyway, that is not important. I set the second point, and I tell the view after the first endpoint and after the second endpoint to refresh the screen. So what does the view do? If you call the view to update, what is the update method? What does it do? It it tells there is a physical view, which is actually the FX or swing panel, right? And so they are all registered. So you can have a single view connected to multiple physical devices. So you can have many, or maybe the same device, but you could have many different views on the same screen. So we have multiple physical views attached to this view. They are all told, it is time for you to draw. So they get into action. They call back, they call this draw method with their renderer. So this is a little complicated. So let me, maybe a little picture will help. Okay, what is going on here? Okay, let's start from the beginning. We have the user drew a line, right? Now the model has a reference to this line, and the model, actually it is the controller which told the view class or view object to draw, to update itself. And there are lots of physical views. I mean, technically, there can be many physical views. So let me call them PV1, PV2, PV3. let's say this is FX, this is swing, and this is art. So they have their own technologies. They are all registered. They are all observers of this view. So the controller told this view to draw. And what does the view do? It tells every one of them, look, it is time for you to draw if you want to. And what do these guys do? They all call back a draw method here. So there's a draw method here, and they supply their own renderers. The FX has its own renderer, the swing has its own renderer, the art has its own renderer. Those renderers are passed. And what does this method do? This view class doesn't know what kind of technology is being used. All it gets is this renderer object, and it tells the line object to draw itself. And what does the line object do? It takes the two endpoints and ships them to the corresponding renderer's draw method, and the line gets drawn. That is conceptually what happens. Let's go back to the code and see how it happens in Java. All right. Okay. Once again, which clause is this? This is a view. All right. The view is told here, update the screen. And the view is telling every listener, which are the physical views, time to do things. And the physical views, I don't know if I have any of them opened here. Okay. If you look at the view subpackage of GUI, it has two subpackages, renderers and views. So there is an FX view and a swing view. FX view has a corresponding renderer, FX renderer, and swing view has its own renderer. So when you create a new type of technology, I mean, a new view for a new technology, you also have to create a renderer for it. Actually, we took a look at FX renderer. So if you look at FX view, it essentially has the whole thing, whole what do you call it, window for drawing. So it includes an FX panel where the actual drawing is done because that has a canvas. And to draw, when it is told to draw, it creates a renderer and gives it to the draw method of the view class. This is that logical view, which doesn't know anything about the technologies. And here is the FX panel, which is actually doing the drawing. I mean, which has the canvas for drawing. And it sets up its panel in some way and then creates or gets the FX renderer. I told you for every type of technology, there has to be a renderer. So it gets the renderer and sends it to the draw method of view. And what does the view do? It gets the physical renderer and it goes through every shape and it gets the shape and then tells the shape to draw itself. So if you are going to a line, if you're drawing a line, you will come here, render, line gets the renderer, FX or swing or whatever, and it draws the line using the draw method of renderer, and that gets it drawn. We also need to see how undo and redo are done. So there is actually this is fairly simple stuff. As I told you, there are two stacks. One is the history stack and the other one is the redo stack. So the history stack will keep accumulating command objects. As you can see, it's a stack of commands. As and when you create a new command, you will be pushing it onto the stack. So what I do is something fairly simple. When you start a new command, we completely clear the redo stack. So no more redos are possible when you create a new command. You can only do undo from that point onwards. That makes life a lot easier. Okay. So when you create a new command, issue a new command, like drawing a line, it gets pushed onto the history stack. So assume that you drew a line, then it will be pushed onto the history stack. And you can see where it is coming from. It's a line drawing state here. So when a new line is being started, a line command object is created, as we saw, and the line drawing state pushes that, gets it pushed rather, onto the history stack by calling begin command. So that gets pushed, and when you want to undo it, when you press the undo button, you will end up here, and you will be making sure that there is something to undo, pop it and push into the redo stack. And when you want to redo, it will pop the command from the redo stack. And if it can be redone, not every command is redoable, like saving data to disk in this program is not redoable, right? So redo stack.pop, it pops the redo stack and pushes it back onto the history stack, so that if you want to undo it, you can do that at that point. And when you undo something, this may be one of the last few things we need to see actually. When you are undoing something, all you do is remove that shape from model. When you are redoing, we call execute, put that shape back into model, because you're remembering the shape. So every command object remembers the shape. When you undo, remove it from the model. And when you redo, call execute to put it back into the model. That's it. Questions? It's been a long lecture. Any questions? All right, then let's stop at that point. Let me, this week and next week, we are doing the drawing program. Go through the code. Next week, all the questions will be on the code. This week, great part of it is on the design. So let me go and create the breakout rooms. Let me also stop recording. And I will make the stuff available to you.